Now we look at an exponential model corresponding to the actual Brussels sprout temperature versus time graph that was provided on the worksheet. Students estimated coordinates on this temperature big T versus time little t graph as 765, meaning after 7 minutes the temperature was 65 Celsius, and 40-35, meaning after 40 minutes the temperature was 35 Celsius. We also can tell from the graph, at the end the graph falls off and follows its asymptote, that the asymptote tends to be about t equals 27. The big T isn't written there, but it should be big T equals 27. Okay? We might even pin that in, big T equals 27. Of course, that's Celsius temperature and everything's falling apart here. Okay? Now, this is what I call exponential. It's an exponential model T plus TD0 b to the T plus C. Now this TD0, what's the meaning of that? That means TD is going to be our temperature difference between the actual function and the room temperature. Remember, it's the temperature difference that counts because that's what makes the temperature change. The greater your temperature difference, the greater your rate of temperature change, so the greater the slope of the graph, and we can certainly see that that's true. Greater temperature difference here implies a greater slope than here where the temperature difference is less. So the temperature difference is actually a function we're going to be able to model first, then we'll be able to come back to this. But the T sub D0 is a temperature difference at time 0. It's this difference here between here and here on the graph on the big T axis. Now, we don't have a good way of modeling this thing unless we happen to know the asymptote, or unless we can somehow figure out what the asymptote ought to be. So what we do is we model the temperature difference function. TD is a temperature difference. Again, the temperature on the graph minus the 27 Celsius room temperature. So at 765, this means the temperature is 65 Celsius. We're going to subtract the 27 Celsius and get a temperature difference of 38. Similarly, when the temperature is 35, the difference is 8. So we have the points, instead of 765, 738 for the temperature difference. Instead of 40-35, 48 for the temperature difference. And now we can say that we don't have to worry about the asymptote C. The temperature difference is just the original temperature difference times b to the T. Because if we look at this function, if we subtract off the asymptote is C. We're subtracting off C and we're just left with TD0 b to the T. That's the function we're going to be able to fairly easily model. So what we do is we take our model, TD equals TD0 b to the T, and plug in our data points for T and TD. Our data points, you recall, were 738 and 48, and when we plug these in, we get these two equations. Plugging the 38 in for the TD here, the 7 for the T here, and similarly 40 for the T and 8 for the TD. So we have these two equations, and now we're going to see how to solve them.